Hello everyone, my name is Alan Holowecky. I'm one of the Senior Product Managers on the Upper Extremity team. And what I want to talk to you today is give you an update on our Upper Extremity Shoulder Trauma products. So when we look at the Upper Extremity products, we're talking about AC repair, clavicle fracture, and also proximal humeral fracture. And we have a lot of technology advancing these things. And I want to talk to you about some of those that we have. So we have continued success with the dog bone button. You know, we see this because we're able to use smaller tunnels. Using fiber tape gives us stronger constructs. And you also have the flexibility with the dog bone button. Since you attach it separately onto the sutures, you have the ability to make different constructs, different cinching constructs, more anatomic, whatever your desire is. We do have new instruments and systems available, and this is what I'm going to talk to you about here today. The first one being new AC guides. We continue to develop AC guides to make it easier for you to drill both the clavicle and the coracoid tunnels. And the guide that we have here gives you a hook that you can rest on the medial side of the coracoid, as well as adjust medial laterally on the clavicle. So here's an example of the guide. So we have the guide arm into the guide adapter. And you can see as we come with our cannulated drill, it's going to hit right at the center of the laser mark. You have a 12 millimeter offset, which will put you in the center of the coracoid. As you can see here, we're resting or palpating medially on the coracoid, getting our position, and now we can rotate that guide up onto the clavicle and get our exact position. So once we have our position on the clavicle and the coracoid, then we can drill through with our 2.4 or 3 millimeter cannulated drill and then complete our repair. So technology is also advancing the way we do our chronic AC repair. With the advent of going to smaller tunnels and stronger constructs, we've gone away and discontinued the graft rope, which required us to drill large 6 millimeter tunnels in the clavicle and coracoid. Well, to fill up the gap or the space needed to do that chronic AC reconstruction, you yourself have come up with a nice technique where you can do a dog bone construct and then do an allograft wrap around the coracoid. The challenge is the ability to do that in a repeatable and simple manner. And we have two instruments that we've developed that's going to give you that option. One is a curved coracoid passer, and the second is a flexible obturator, which enables you to dilate around the coracoid as you pass your autograft or allograft. So with anything, as we're working medial on the coracoid, we want to make sure that we find the bone and stay on bone. So we'll take the guide through a small incision, find the top of the coracoid, and then go medially. And as we find it medially, we'll lift the guide up, and we're able to now pass a fiber stick through the cannulation of the guide. Ultimately, you want to come down with a grasper anteriorly on the clavicle and laterally on the coracoid. And what this will give you is a suture to shuttle around the coracoid. Now from here, you'll take the flexible obturator and tie that onto the medial end of the fiber stick, shuttle that through, and on the back end of the flexible obturator, you'll have your whip stitch graft limbs attached. And as you dilate around the coracoid in one step, the graft will pull through. Now from here, you have a lot of different options of what you can do with your graft. You can use the same instrumentation and pass that posteriorly on the medial limb posteriorly on the clavicle to give you more anatomic repair. And then it's your choice on how you want to fix it in the clavicle. Most surgeons will have really just gone to suturing the graft limbs together over top the clavicle. You have sufficient mechanical fixation with the dog bone construct, so you don't necessarily need that graft to support much of the load, if any. So here's a case that we've done. We have our mechanical fixation. We've done a cinching construct with the dog bone, which is where you see the suture tails here. Now we're coming into that same incision, finding the top of the coracoid, and as we're looking with a 70-degree scope, we can see the tip of the guide. So now what we're going to do is we're going to pass our fiber stick through. And now here you have an optional step where you can retrieve that fiber stick out the anterior cannula. And then we're going to come down with our grasper laterally on the coracoid and anterior on the clavicle to get our shuttling suture. Now we'll tie the limbs onto the flexible obturator, and you're going to see here how it's going to come around the coracoid. So it's a tapered obturator, so it helps get through that pec minor and other soft tissue. And then as we get around, it's going to dilate. And then as you can see here, we have our graft limbs attached to the end of the flexible obturator, and we have it around the coracoid. So we've done a very good job so far of repairing the CC ligaments, holding that reduction. However, there's still a hot topic now on the AP stability for the clavicle. And there's a lot of different ways and a lot of different discussions that are going on about how to address this AP stability. And one way that we're looking at doing, and we're coming out with a guide system to help you do that, is using the internal brace. Now, we've had success with the internal brace also in the ankle as well as the knee. We're also going to apply that to the clavicle for AC repair. So what we're going to give you very shortly is an offset guide, a 5mm offset guide that's going to enable you to go anterior on the acromion and also the distal clavicle with a 5mm offset, and you're going to be able to do a 3/5 swivel lock in the acromion and bring that over with a fiber tape to a 4/7/5 swivel lock in the distal clavicle. Now, we all know one of the concerns about using fiber tape is we have to tie it. And you do have a knot stack, which we can mitigate by tucking those posterior on the clavicle. However, there is a need to have knotless solutions, just as we've done so with the knee and in the ankle syndesmosis. So what we're developing now is a knotless tightrope construct that's really optimized for AC repair. And when I say optimized for AC repair, we're going to have a Tophat device, which is a unicortical clavicle insert with 2 independent knotless tightropes on there. So you have the redundancy, and plus you'll have the added strength of the construct, which will be equivalent to 2 fiber tapes. You'll have to be able to pass this through the clavicle and coracoid and attach a dog bone button on the bottom as your coracoid fixation. The result is going to give you a nice, low-profile, knotless, strong construct. So we've taken this technology that we developed on the AC repair, and then, as you know, we've moved over in the clavicle fracture world. We have continued development on implants and instruments, and as we see, one of the big advantages of our system is the ability to use coracoid fixation. And as you can see here in this graph here, over half of the lateral fractures that we've done have implemented some kind of coracoid fixation. The one challenge, though, we have using the lateral plates, though, with the coracoid fixation is inserting the distal 2.7mm divergent screws. So we've come up with a guide system that's going to enable you to be able to drill, measure, and insert a screw all through a guide tube. So we'll see an example of here. You have a left and right guide. You have 2 points of fixation. One will fit in the K-wire slot in the end of the plate, the other through the threaded hole in the plate. And this will give us a nice, tight fix. So we're going to eliminate all of the play. So now what we have is our guide sleeve, and this is where everything's going to work through. So it's a press-fit sleeve that fits into each of the holes. We have a special drill that's calibrated so you can measure off the drill. So we'll drill, and you can measure the screw length off the drill if you so desired. We also have a measuring guide, a depth gauge, to find your screw size. And then a special driver that you'll be able to insert the screw and put that screw in its proper orientation. From there, you can remove the guide sleeve and then move on to the next. We're also adding additional plates based on the market need. We have 5 plates that we're going to be releasing relatively shortly. One is a straight 7-hole plate. This is designed for midshaft fractures. So if you have a smaller patient or you have a straighter clavicle, you're going to have the ability to better match the anatomy. Also, we're going to have a shallower curved distal plate for those cases where the curve on the existing plate is maybe too great. You have the ability to now have a plate that will help fit. As well as we're going to have a 10-hole plate. And this 10-hole plate is going to give you the ability to, if you have severe comminution or an extended fracture pattern, you're going to have the ability to actually modify or bend the ends with the recon segment medially. Now, just like with the AC repair, we're having knotless a solution which will be available shortly, and that will be with a knotless plate button. So just as we saw with the AC repair, where we have the two knotless tight ropes in a Tophat or an insert device, we're going to have one knotless tight rope that's going to be threaded onto the clavicle plate button and give you a nice knotless, low-profile solution. Now, proximal-humeral fracture, we have some good developments going on here. We have a hybrid 3, 5, 7, and 9-hole plate in development. And when I talk about a hybrid plate, we're talking about the different screws. So what we're doing now is we're going to have the 6 most proximal screws at a fixed angle. And we're still going to give you the ability to have a variable angle in the calcar screws. So this is going to be able to fit the plate to the anatomy, not to make the anatomy fit the plate. We've also reduced the proximal end of the plate by 4 millimeters. And what this is going to do is to help better plate placement and help avoid any kind of impingement in your repair. Just like with the distal clavicle, we're going to have the same drill, measure, and screw insertion guide that you'll be able to insert all of the divergent proximal screws with. And it's not only just the instrumentation and implants, but we're also looking at different materials. We've had good success with the carbon fiber peak plates in Europe, so we're looking to bring that technology here for proximal humeral fracture hopefully in the near future. Now, it's not just the metal and implants and screws and instruments. Another key feature for our fracture repair is our biologic component. Now, we do have several great options that you can help augment your repairs. We have QuickSet, which is a cement-based material that can help augment your proximal humeral and your clavicle fractures. And if you prefer a DBM option, we have StimuBlast and Flexograft. So we have a very complete and comprehensive system for upper extremity trauma. We've done a very great job with AC repair. We've got a lot of exciting things coming in the clavicle fracture with continued success with coracoid fixation and continued development with our proximal humeral fracture. And then also to wrap that in with the biologics gives us a nice comprehensive system to treat our fractures. Thank you.